So let's look at the basic concepts of networking, and of course, the mother of all networks, the Internet. The Internet is a global system of interconnected computer networks that use the standard Internet Protocol Suite, often called TCP/IP, although not all applications use TCP, to serve billions of users worldwide. It's a network of networks that consists of millions of private, public, academic, business, and government networks of local to global scope that are linked by a broad array of electronic, wireless, and optical networking technologies. The Internet carries an extensive range of information resources and services, such as the interlinked hypertext documents of the World Wide Web, WWW, and the infrastructure to support email. The origins of the Internet reach back to research done in the 1960s, commissioned by the United States government in collaboration with private and commercial interests to build robust, fault-tolerant, and distributed computer networks. The primary precursor network, the ARPANET, initially served as a backbone for interconnection of regional academic and military networks in the 1980s. The funding of a new U.S. backbone by the National Science Foundation in the 1980s, as well as private funding for other commercial backbones, led to worldwide participation in the development of new networking technologies and the merger of many networks. The commercialization of what was by the 1990s an international network resulted in its popularization and incorporation into virtually, I'd say, every aspect of modern human life. So as of 31st December 2017, more than 4.1 billion people, nearly 55% of the whole world population, use the services of the Internet. Now, I'll put that in a little perspective here. That's 95% of North Americans and about 85% of Europeans are Internet users. Now, before talking about the Internet Protocol, or what we call IP, we should know what a protocol actually is. A protocol is simply a set of rules governing how things work in a certain technology, so that there is some kind of standardization. Protocols are also typically in charge of sending the right data to the right PC, making sure the data gets to the right program, as well as organizing the data to be sent. Protocols are to computers what language is to humans. For instance, this course is in English. To understand it, you must be able to understand English. So similarly, for two devices on a network to successfully communicate, they must both understand the same protocols. So I know we're going to talk about this in detail later, but we'll talk a little bit now about IP to better understand the Internet. Internet Protocol, IP, describes how data packets move through a network. So when you have a protocol, you are sure that all machines on a network, or in the world when it comes to the Internet, however different they might be, speak the same language and can integrate into the whole framework. The IP protocol standardizes the way machines over the Internet or any IP network forward or route their packets based on their IP addresses. So along with addressing, routing is one of the main functions of the IP protocol. Routing consists of forwarding IP packets from source to destination machines over a network based on their IP addresses. An IP address is a unique address identifying a machine, which can be a computer, a server, an electronic device, a router, a phone, you name it, on a network, thus serving, routing, and forwarding IP packets from source to destination. Basically, every computer connected to the Internet is given an IP address by the Internet service provider, and the computer becomes accessible to others via this IP address. So let's see what the Internet looks like on its most basic level. Here we have a home network with a router given by the Internet service provider, or ISP. Remember that modem that's given to you by your ISP. And the devices it connects to the internet. This is a corporation with a lot of end-user computers and servers as well. There's a public body here, again, with a lot of servers and a lot of end-user computers. Here is a hosting company with a web server farm hosting to their customers. Now here's a cloud provider such as Amazon Web Services, hosting a lot of servers again. And here there's another home, and they're all connected to each other over telecom company routers.